right. So this is probably the first Windows laptop today. Okay. Uh, Not sure though. It should be probably in a few quarters. So yes, it is still Mellanox presentations. If you guys heard about the news. Okay. Um, so today I'm going to talk about Mellanox software and RDMA, and probably more than I'm talking, I'm probably here to hear you all the pain points that you have faced and what more can be done. Um, I guess Mohan has set up some of the RDMA baseline. I want to ask before I jump in more in the slides. How many of you have already used RDMA or intend to use or you use on a daily basis or in your clusters, right? Okay, okay. So I see half or I'll probably jump through a few slides. S- um, so first, let's talk about what RDMA is at really 10,000 feet from the administrator or users level. Then go through the challenges that we face, our users face with using Mellanox software and RDMA, and how to containerize them, and some of the future ideas that I hear from some of you already um, in doing so. So RDMA, as we know, is a kernel bypass method. Instead of using TCP/IP stack, we use a different reliable transport, which is RDMA. That bypass is a system call, and bypass is, when I say bypass, it's not invoking the system call to do the data transfer, but there is obviously a kernel involved in ensuring that one process does not see the data of the other process. So um, RDMA does that today, and I guess in Mohan's slide there was application latency being mentioned, being in few nanoseconds. So one application in one server talking to other application in a different server across the network is few nanoseconds, and that's what enables large number of HPC applications to perform a very low latency operations at a much uh, much more efficiency. Um, so these are the three things that we get out of RDMA. Now, the moment and how is it done? When we bypass the kernel, when we bypass the TCP/IP stack, somebody needs to talk and transfer the data out on the wire. So the application is talking directly with the hardware, the HCA, to send the data out and get it back. And the moment the application starts talking to a hardware, we have three or at least two compatibility issues. One is in setting up the resources to do this transfer. That means the user application running, talking to the hardware through the kernel. How does it set it up? All the resource uh, between different kernel versions, different OS versions. Um, and the second compatibility is, now that the application is talking to the hardware, is that application compatible with the hardware that he is talking and the firmware that he got? So these are the two main challenges that we face. The third challenge is, well, okay, I make everything um, ABI compatible. I still need to package them, and with containers, we quite a lot of us have talked about it, the portability issues. So, what are the portability issues that we'll see in a moment? So, if you see with Mellanox software, it comes with several different packages. We we have all the user space libraries, vendor specific libraries, all the Mellanox drivers. It comes along with the firmware, several of the diagnostics tools, the performance analytics tools, and the kernel pieces. So often the user demands to move at much faster pace to use Mellanox software, because every quarter they get new features to roll are bundled with the OFED drivers. So even though they are available as part of the OS distros, there there's a strong demand to consume it outside of the OS distributions because of its space and the features that comes along with it. So until now, what we have been doing is most users have consumed a complete Mellanox software package, mostly in the labs environment, where kernel, user space, firmware, everything bundled together comes as a single monolithic entity, a software package. User obviously has a choice not to pick and install one of them, but traditionally it's been done that most packages are installed together, and um, and in that process, on several occasions we missed that with containers, the user could be using a different library of Mellanox software in user space and running a different kernel driver. So, and that brings a basic compatibility issue, saying, well, this doesn't run anymore. I installed Mellanox software 4.2 in my user space, and I'm running my 4.1 kernel in my lab, and they don't work now. What do I do? And that's one of the primary problem that we addressed. So uh, these are the main portability problems that we see, and I like to hear if there are any others that I need to get back to our team. Um, how do we make containers portable? Um, before we jump there, portability is seen at a very different levels by several different people. Uh, we from the network side see in terms of how we make the containers portable between our user space components and the kernel components, and how we make that life easier to package the containers. So that's my area of focus in portability here. Um, we obviously want the MPI applications to be running in the laptop as well as in the lab, um, regardless of where they are running. It should be obviously portable across different kernel versions that user picks up. Um, the big challenge right now, which we haven't solved yet, is the upstream version of the kernel and the Mellanox software. There are some deltas in there, and can that be made portable? So that's the last point, third last point. And how do we make Mellanox software compatible across different versions of flavors, starting from 4x to beyond? So while we work on the portability, the common questions that user comes across is, what do I package in a container and what I shouldn't? Do I package Mellanox software in it, or I should do a bind mount? Um, why should I package Mellanox software? Because I hit these issues where they are not compatible. What about the diagnostics tools? Do I package in container, or I just keep it in the host? That's if I'm packaging Mellanox software, do I package my application also inside, which is using this Mellanox software, or I keep it outside? And it's kind of tricky where you say, I want to package partial, but I don't want to package some part of it. So if we go back to our first slide, so these are really very high level software components. I'm sure you have a lot more software pieces flying with each other. So very high level, we have applications, then we have all the middlewares, and then we have the core Mellanox software component to interact with the hardware, and the kernel stack and the HCA. So if you split out, what do you think can be um, containerized and what shouldn't be? Um, so we think there are two options right now, and probably there are more future-looking options that we can enhance the container ecosystem for. Uh, let's see those two options. So I'm going to jump this slide and come back in a moment. Um, there are two options. Option one uh, is containerize your application and all your libraries. So in last session we saw the natural friend in the last slide is about packaging the libraries, and I think um, if you package your application along with the middleware and the Mellanox software components, it should work in most environments that you have. So this is one option, but now that brings an issue saying if I have packaged my MPI application inside the container and I'm going to invoke this container from my host, uh, but that MPI version is different than the one that is inside the container. So what do I do now? Can I take this out component? Maybe. I'm not an MPI expert here, but that's probably an option. Now, if you take out the MPI component out, but your application written on top of MPI is using those APIs, so when you bundle an application, you have linkage errors because underlying libraries doesn't exist. So what do you do? Um, so at best, I think um, I think it's good to bundle the the Mellanox software component inside the container and the application, and keeping everything else out, which the infrastructure or the lab that provides it. So one option is to so the second option that I'm jumping here is trust your infrastructure, who expect you to provide all the necessary components. So in this case, probably an MPI is a component outside, which plans to use the RDMA Mellanox software libraries. In this case, the job scheduler schedules all the containers, which only contains the application and the core libraries that needs to interact with the RDMA stack. Now, can we take this component out of the picture and host to provide it? I guess the answer is yes. The issue is then comes back, can I reproduce it? And in order to reproduce, the component that is running on the host should be a reproducible component um, to be kept in an isolated manner. So can that be running as a container? Possibly, yes. You can package those application as one container and bring it in when it's needed. So um, so so these are the two set of users that we come across where they bundle all the applications and the pieces of Mellanox software all together in one container. That gets you the most reproducible behavior. And the second option is to take out all the middleware pieces which are dependent on the infrastructure. If you want to enhance it, what can be done? So one way is saying, okay, I don't have my MPI libraries, Mellanox software inside the container, but my container has to still run on that infrastructure. So can we use resource definitions or the metadata in the container to request that? So one option is to basically describe all your metadata in the container. So today, eh, on on a non-singularity platform, we have on Docker or Kubernetes. It's more Kubernetes definition than a Docker is to have custom resource definitions, and um, the resource definition that you say when I run this container, I need this resource. So can it be enhanced that way, where you say my application needs to know um, that it needs to run an RDMA fabric, it needs to run on an MPI fabric. Can I bring in all my MPI components and RDMA components from outside? And then the the Singularity or the runtime environment can bring in those in and do the bind mount at that point of time. And by doing so, you possibly get best of both worlds: the reproducibility of your container, the reproducibility and the constant image which you expect to run. That's second. And your application is still intact in the container. And uh, this may be the way forward to have all the moving pieces still containerize in itself uh, to get to get what we want to achieve. So that partially answers or try to address the key area of uh, how the Mellanox offload is containerized and still achieves what we want. Um, so the common question that's been asked is, are they compatible? So what we made sure or going to make sure going forward is these are the Mellanox offload versions. Some of you might be aware of it. Um, I explicitly want to call that out. So 4.2 and 4.3 versions and lower are not compatible. I mean, it could run well. It's just that the QA teams and the internal teams does not really do the testing well enough to qualify them. So they are not GA. But 4.4 and higher should be compatible with each other. So what does that mean? What it means is that you pick um, the prescribed OS, say CentOS or RHEL or Ubuntu, on which 4.4 Mellanox offload kernel is installed, and then you bring any container which is compiled with 4.4 or higher user space, and it should work. That's 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 very basic baseline that we would like to set it up. The way the kernel works, most system calls are supposed to work. It's an ABI. So this is the baseline that um, we are heading towards. Similarly, you have a 4.4, 4.5 or 4.4, any higher kernel version, and a lower Mellanox offload user space. It should just work. There shouldn't be any ABI issues. That's again baseline. However, there are few features with regards to performance that is being enabled by the application, requested by application, and the kernel supports it. So those are not going to work. So for example, 4.5 has some of the out of order data placement in the fabric and in the network, and 4.4 is just not aware of it, saying, can I make use of this fabric and the kernel benefit to do an out of order data placement or not? And in those cases, you would see a lower or the same performance that's been seen with 4.4. And in those cases, there is obviously a need to upgrade to 4.5 for the user applications to make use of it. So those are the pretty minor, low-level details that that really the developer needs to be aware of. What features they want to make use of, which is available from the kernel. Um, so um, these are some of the slides that I took help of from Michael. Thanks, Michael, for the help. So 3.x of Singularity brings the unprivileged part of it in I guess in a very big way, and uh, RDMA requires some of the privileges. Um, the main privilege here is the IPC cap lock. Anyone came across hitting issue with it? Okay, luckily no so far. Um, so uh, the first slide, which I took at very high level, RDMA application does data pinning to do a data transfer from one to the other application. So large number of applications that we have come across in database, HPC, cloud, they pin the memory from which that memory address is being advertised to the other node, and read and write happens from that node by all the other nodes from this memory. So you need to advertise this process memory to the other process on several thousand nodes, and you pin this memory on a node. And when you pin the memory, you need a privilege, because once you pin the memory, that's not available to any other process you're running in the share on this cluster or on this node. So now with Singularity 3.x, when we go on privilege, you explicitly need to pass this capability when you run in the container. So that was my question in the morning, that whether the privileges are on per user or on per container. And since they are on the user, we need to set the privilege on the user. And then when the container starts, the user needs to be aware that he needs to he needs to request a capability, and the administrator has granted that capability. So this is something to take care. This would probably the first problem that user would encounter when they move from 2.x through 3.x. How can we make life a little better? So this is right now the repository that we set up for all the Singularity definition files. If you want to containerize your application using Mellanox software, I guess some of you might have already done this in your setup. But if you want something quick and easy, latest, all the definition files are here, and they are all stacked files. So you can use CentOS or Ubuntu, and then all the three platforms you can build the containers out of Mellanox software, and everything else will be on top of it. So this will be your baseline, and then more the actual application you can bundle using your definition files. This is the last slide. So we are looking beyond Singularity 3.1 is so there are two classes of users that we come across. One is they use containers for isolation, and the second class of users is containers for primarily image versioning or their application packaging, where they don't need an isolation. And so I guess until so far, most HPC users from the lab's perspective is not for isolation, but for application packaging. And the machine learning, AI, and the cloud side of the users, they want isolation. And so that's where we have been working on, is to have a RDMA running in the isolation. If there are two containers running, they shouldn't be able to see their device, resources, processes from one to the other container. And it's a solved problem in network using network namespaces. RDMA is another network device who provides the isolation. So all the network devices live in their own namespace, and that's what we are working on. These are the patches links in case if some of you are interested, is to have RDMA devices to have in an isolation mode. Since I have little time, I just want to throw light on to the Sylabs team. RDMA C group is part of the OCI spec for probably a year now, and I guess I see in some of the templates too here. It's available from 4.11 and higher kernel. So it's not yet part of the 7.x RHEL release, but most updated kernels have it enabled by default. SE-Linux, RDMA supports InfiniBand network primarily make use of the SE-Linux policies, which is available from 7.5. So, so there are various options from the kernel side to isolate the RDMA device from one to other. C group addresses the resource part of it, that how much of the RDMA resource one process or set of group processes can get. SE-Linux does the isolation at the P key level, the InfiniBand P key, so you can create multiple partitions and containers live in that partition. The partition does not address all the issues because you have rocky devices as well from the networking side. So the network namespace support isolates all the RDMA devices in their network, and then every container gets their own RDMA device to work with, including statistics, connection manager, and rest of the features that you get with a RDMA device by default. So as user request, we would be happy to integrate these kernel features into the orchestration layers. So that's all I have.
Any questions for Parav? Guy at the back. I know you're loud, but just hold on. Yeah, try not to yell this time.
I'll try not to be quite so loud this time. Yeah. Stand across the room with this. Okay. Yeah. So I saw that. I'm wondering how flexible the user space is. So I saw that you have support for both Ubuntu and CentOS. What if I want to build like a BusyBox container or an Alpine container? I mean, is the user space that flexible? I just don't know how it's compiled.
I think it should compile. I don't see an issue. I guess user never tried to do BusyBox or Alpine, so.
Just as examples, I'm just wondering how flexible it is.
So CentOS, Ubuntu, RHEL are the three. Fedora as well. Quite a lot of our internal QA and tests are on Fedora as well. So these 4 OS, I'm sure, are pretty solid. It should be able to compile, no issues.
Okay, cool. And then one more follow-up. So on the slide where you had kind of the compatibility between different versions, I think that you were talking about the compatibility, but yeah, between 4.4 and 4.5.
Yeah.
So this goes back to, I guess, BJ's talk just before this, and having like there you are. And then having all the prime numbers, snuck up on me there. Having all the prime numbers and having, like 23 years out, is this container still going to work? So I wonder, I mean, clearly you can't just say moving forward, we're always going to be backward compatible, to 4.4. But how are you trying, what are you striving for here? How much backward compatibility are you trying for?
So at least one version backward compatible is going to be supported for sure. So 4.6 is almost going to be out pretty soon, in probably a month. So 4.6 is going to be compatible with 4.5, and since those two are compatible, it should be compatible with 4.4 as well, because 4.5 is compatible with 4.4. Well, they won't see it. So let's say you are querying. So we added a feature called on-demand paging support for SRQs, so that you don't have to pin the memory. that's a new kernel feature to on shared receive queues. And 4.4 is not aware that he is supposed to query this feature to make use of it. So anything that comes up new that the old one won't be able to make benefit out of. It won't benefit because he doesn't know that he needs to invoke this API, right? So you say create a shared receive queue for me with ODP enabled. Nobody is going to invoke that call on 4.4 because he doesn't know that something of this exists. Now, if we have a 4.6 calling that API on 4.4, then that's going to fail because it's an unsupported feature. It's like any other system call of the Linux, where if the feature is unsupported, he would throw an error saying it's unsupported. Yeah.
So what about compatibility with the inbox drivers?
Yes.
Because for instance, I may want to run, or I may have a system that can only run purely open source software.
So Mellanox software is open source, including sources and the RPMs. It's all pretty well GPL'd. So it's an open source. I don't have a good answer right now how to make a Mellanox software kernel modules work with upstream. We as a developer level, we strongly try to make sure that that's what it is. It should work, but I cannot go back and change the past right now.
Sure. Yeah, it's about looking forward,
Yeah.
right?
So we have a class of applications called DPDK, which is primarily used by the networking side, where they implement the router and switches all into a user space. That's based on the Intel started a DPDK framework, and that uses RDMA, and all of that is compatible with the Mellanox software. So so I should go back and check with the team what's the plan there to make that two compatible with each other. Most things should work, but there is no GA or QA done, so I don't want to commit there.